All right, folks, today we're going to take a look. We're going to use the skills that we have been learning so far, and we're going to try and find another method to solving a quadratic equation if it is not factorable. Oops. So let's start off with our quadratic formula as we're discovering it here. So we already know how to solve a quadratic equation if we're working in standard form. We factor it, we set those factors equal to 0, and then we isolate for x. As a quick example, we should be able to handle something like this here. Let's try factoring this. Now we could factor this as a complex trinomial, but it's even easier to first factor it as to try and find a common factor, and here we can find a common factor of -2, leaving us with x squared plus 7 plus 10. And then we can factor as a simple trinomial what's inside these brackets here, leaving us with, 7x there in the middle. -2 times x plus 5 times x plus 2. And from here, we set each of the factors equal to 0. So x plus 5 equals 0. We isolate for the x. That means x equals -5. And again, with the other factor, x plus 2, we set that equal to 0. We isolate for the x. We find that x equals -2. Now, what if we're given an equation that does not factor? And you can try this out. You can try and find a number that multiplies to 1, adds to -3, and you can quickly see that you're not going to find a solution here. So if we're working with a problem that does not factor, then we're going to try and discover here a strategy that we can use. And this is where the quadratic formula comes in. We're going to handle a quadratic equation just in standard form, and we're not working with an example here. We're working with the general quadratic equation. Now, and that means that we're dealing with an a, b, and a c rather than actual numbers here. Now, we're going to manipulate this equation so that we can isolate for our x. The first thing we want to do is we will, in order to almost factor out from the left side, but not so much factoring out an a, but we're going to divide every single thing here by a so that we can have our x squared term on its own. So that means we're working with divided by a divided by a. Well, 0 divided by a on the right side, that still equals 0. And on the left side, I have ax squared divided by a. That just leaves me with x squared. And then I have bx divided by a, so that's b divided by a times x. And c divided by a. Perfect. Now from here, just in a similar way to how we completed the square in the past, we're going to separate this third term from the first two. Okay, so we're going to subtract c over a from both sides in order to move that term over to the left-hand side, or sorry, to the right-hand side. So we have -c over a on the right-hand side, and on the left side, we're left with x squared plus b over a times x, and that's it. Okay, now from here, we want to complete the square. We want to create a perfect square on the left-hand side. Okay, so if we are coming up with a perfect square on the left-hand side, then we need to add a term, b over 2a squared. If you're a little bit confused how we came up with this term here, this b over 2a squared, if you're confused there, then double check your lesson on completing the square from earlier. Okay, but from here, if we add that b over 2a all squared, if we add that to the left-hand side, we have to do that to the right-hand side as well. So plus b over 2a, again, all squared. Fantastic. Now from here, we can factor this perfect square, and factoring this perfect square leaves me with x plus b over 2a all squared. There's my left-hand side, and you can see how we're almost breaking it down. We're manipulating it in a way so that we can isolate for this x at the end. Now, on the right-hand side, we're going to expand this out a little bit. So if I have b over 2a all squared, that's like squaring my numerator and squaring my denominator separately. So my first term stays the same, -c over a, plus, and then I'm left with b squared over 2 squared, which is 4, times a squared, which is just a squared. Oops. Now, from here, we're going to just keep right on moving forward, and we'll try and write out the right-hand side as a single fraction. So in order to do that, if we're going to add these fractions here, then we need to work with a common denominator. Here our common denominator would be 4a squared, and that would bring us to negative 4ac in my numerator here on the left, divided by 4a squared plus b squared divided by 4a squared. Now that my denominators are the same, I can manipulate the numerators. I can add those together, write it as one fraction. So I'm working with b squared minus 4ac, all divided by 4 times a squared. Okay, now on my left-hand side, we've left that alone for a little bit here, but let's try and break it down even further. We'll use our inverse operations, our opposite operations, in order to isolate for this x. So here I have, let's just rewrite what I'm working with, x plus b over 2a all squared. What I need to deal with first is this little square right here. Okay, so the opposite of squaring something is square rooting something. If we square root something, if we square root both sides, we need to take the positive or the negative square root, okay, of the right-hand side here. So we'll do that. Our square and our square root on the left-hand side, those cancel out. We're dealing with here, let me see, on the left-hand side, just x plus b over 2a. I guess I don't need those brackets anymore. And on the right-hand side, plus or minus. And here I can break this square root apart, right? The square root is right now happening to my numerator and denominator. I'm going to rewrite that so it's happening to the numerator. That's b squared minus 4ac, all under the square root, divided by a 4a squared that's also underneath its own square root. Okay, now I'm going to, geez, I'm jumping all over the place here. We'll copy that over just so we can see exactly where we're working, as I've run out of space. There we are. Now, moving forward a little bit further, I see my square root of 4a squared down here. That's just like square rooting 4 and square rooting a squared. So the square root of 4a squared is simply 2a. So here I'm working with plus or minus the square root of b squared minus 4ac, all divided by 2a, right, where I've square rooted the coefficient and I've square rooted the variable. Now, still, I need to isolate for this x. If I'm isolating for this x, then I need to subtract b over 2a from both sides. If I'm subtracting b over 2a from both sides, actually I can do it up here, minus b over 2a, and down here that leaves me with x plus b over 2a minus b over 2a. Those will cancel out, leaving me with simply an x on the left-hand side. And I can reorder this to write my second term first. So I'll move that over here in front of the plus or minus sign. Negative b over 2a plus or minus the square root of b squared minus 4ac, all divided by 2a. What do I notice here? Both of my denominators are the same. That's fantastic. I can write it as one fraction. So that's negative b plus or minus the square root of b squared minus 4ac over 2a. Now, if you're feeling a little bit overwhelmed at this point, that's okay. We're not going to ask you to derive this equation here for us on an assessment. That would be, if we were asking for that, that would be certainly a challenge problem, right? But at this point, you should be able to follow the math that's going through this here in order to isolate for an x. That's what we did, right? We started off with our standard form of our quadratic equation, and we isolated for x. Now, we have this here, and we can use this in order to find the roots of any quadratic function, if you will. So here I have a times x squared plus b times x plus c equals 0. That was how we started, and it's key that it equals 0 on the right-hand side or on one of the sides, just like before, because if it equals 0, then it truly is, it's the roots we're finding, it's the solutions, it's the zeros that we're finding here. Now, what we can do is we can use this equation, this quadratic formula. That's what this is known as, the quadratic formula. Oops. And we can use this here in order to find our roots of any quadratic in standard form. So when we're unable to factor, that's when we're going to use our quadratic formula. We actually could use it more often than that if we wanted to, but the quadratic formula is more challenging to use than relying on our factoring skills that we've learned in the previous unit. So when we can factor, we still want to factor, but the quadratic formula will be a tool in our toolbox that we can rely on if factoring is not an option, because not every single equation can be factored. So when we're unable to factor, we'll use the quadratic formula. It's used to solve for the roots or solutions or x-intercepts or zeros of a quadratic equation. To use the formula, we use the values of a, b, and c, and we substitute those into the quadratic formula from the standard form equation, right? So again, we need to make sure that we're working with a 0 here on one side of our equation as we're working there. Now, so the two roots would be given by, I know you may have seen the plus or minus, that may have confused you up there. That'll give us our two solutions. Really, I should break that down a little more. So that will give us one solution, that's x equals negative b plus the square root of b squared minus 4ac, all divided by 2a. And it will give us a second solution, which is x equals negative b minus the square root of b squared minus 4ac, divided by 2a. Now, you will see as we work through, perhaps not every time will we be working with different, with two solutions, but we'll see that as it comes up. Now, we're going to try using this quadratic formula in order to find the roots of these two examples. First, we'll work with a, and in this case, we have x squared minus 3x plus 1. Already, just like before, we need to double check to see that one of our sides equals 0. And if it does, then we're good to keep going forwards. In this case, it does, so we can jump right into our quadratic formula. Well, our quadratic formula, we need an a, b, and a c. In this case, there's no coefficient on our first term. If we don't see a coefficient there, there's a hidden coefficient, that's a 1. Right? Our second term, my coefficient, you might think it's a 3 right off the start, but you need to make sure you take care of that negative. So our b term is negative 3, and our final coefficient here is 1. So we're working with a 1, a negative 3, and another 1. We're going to substitute those into the quadratic formula. Now, our quadratic formula, at first, when you're using this, you might struggle and you'll definitely need to use your notes as you're working through it at first, but you will get comfortable enough with the quadratic formula that you'll be able, because you'll use it so much, so you'll be able to rely on it without necessarily needing to, I guess it'll naturally become memorized because you'll work on it so much. So our quadratic formula, so x, remember the quadratic formula is an equation. We need to make sure we write this x equals on the left hand side. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. All right, now we're going to substitute in the values that we know. So we know a equals 1, we know b equals negative 3. So that's negative 3 plus or minus the square root of b, which is negative 3 squared, minus 4 times a, which is 1, times c, which is 1, all square rooted, all divided by 2 times a, which equals 1. Next, we can start simplifying that. So negative times negative 3, well, that's just positive 3. So positive 3 plus or minus the square root of negative 3 squared, that's 9, minus 4 times 1 times 1, that's 9 minus 4. Okay, so we're simplifying it, all divided by 2. And you can see just through some simplification. We've gone from what looks very complicated to something that looks much more easy, much more manageable for us to handle. Now here we have 3 plus or minus the square root of 9 minus 4 all divided by 2. So that is 3 plus or minus the square root of 5, right? 9 minus 4, that's 5, divided by 2. And there we are. Now we work and we find our two solutions. So our two solutions are our first one is x equals 3 plus the square root of 5 divided by 2. And our second solution is x equals 3 minus the square root of 5 divided by 2. Now from here, this step in particular is a part of your solution. We must write it out like this. These are, when we give our solutions like this, our answers like this, then we're writing them out in exact form. So this is the last time in our solution that these will be in exact form. Exact form. Now, in terms of these exact forms, when you move on to grade 11, you're going to be starting to leave a lot of your answers just in this exact form. You're not going to take them any further. But in this case, we're going to practice it a little bit more, so we're going to try and see some context. We'll try and see what this number actually is. X equals 3 minus the root 5 over 2, and x equals 3 plus root 5 over 2. We'll figure out what those exact answers are, because here we're expressing answers as exact roots, already done. Now approximate roots. We're going to round those to the nearest hundredth. So we put this into our calculator. X equals 3 plus root 5 over 2. So I type in 3 plus root 5 over 2, and you can try that as well into your calculator. You should get about 2.62. Recognize we have a dot above our equal sign. Alternatively, you could write that as a squiggly line to represent approximately equal to, or a couple of squiggly lines there. I prefer the dot. You can use your own method. And our second one, into our calculator, we find that x equals approximately 0.38. So our two solutions here as approximate decimals are given as well. We'll jump forward now and we'll try out our last example. And in this last example, we'll see, we'll kind of discover something new that might happen as you're trying to solve your problem. So right off the bat, we recognize the right-hand side does not equal 0. The left-hand side does not equal 0. If neither side equals 0, we need to manipulate the equation so that it looks like a quadratic equation in standard form. So first, I will use my distributive property on the right-hand side. That's negative 2x squared plus 14 equals 20. Oops, plus 14x equals 20. And then I'm going to move everything over to this left-hand side. So I'll subtract 20 from each side. So negative 2x squared plus 14x minus 20 equals 0. There I have my 0 on the right-hand side. That means it's ready for the quadratic formula. If it's ready for the quadratic formula, I need my a term. A equals negative 2, b equals 14, c equals negative 20. From here, we will sub into our quadratic formula. Our quadratic formula, we are hopefully getting a little more used to it. We need to, again, we must write out this x equals, because the quadratic formula is an equation, it is not an expression. The x equals tells us what we're looking for. So x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. Now from here, so that's negative b, well, negative 14 plus or minus the square root of 14 squared minus 4 times a times c, where here we'll have an a as negative 2, c as negative 20. There we are, all divided by 2a. Fantastic, we'll keep looking forward. So that equals negative 14 plus or minus the square root of 14 squared. If I'm working with 14 squared, that's 196. minus 4 times negative 2 times negative 20. Well, 2 times 20, that's going to be 40. 4 times positive 40, that's going to be negative 160. Fantastic. All divided by, whoops, I left this 2a in there. My a term is negative 2, isn't it? All divided by negative 4. And that is negative 14 plus or minus the square root of 196 minus 160. We can do that in Scratch over here if we want. 196 minus 160. 36. Fantastic. The square root of 36. I wonder if we recognize that. Square root of 36. We know what that is. Plus or minus 6. Right? All divided by negative 4. And there we are. Then we can break it apart into two solutions, right? So first we'll take that into our first x equals negative 14 plus 6 divided by negative 4. And our second solution will be x equals negative 14 minus 6 divided by negative 4. Right, so my first one, oops, maybe I should have left myself a tiny bit more space there. Fantastic. Negative 14 plus 6, that's negative 8 divided by negative 4, which gives us negative 2. Whoops, positive 2. And the other one, negative 14 minus 6, that's negative 20 divided by negative 4. That equals positive 5. So our two solutions here, x equals 2 and positive 5. There we are. Now, please don't forget, folks, what it is we're finding here, right? When we're finding these x values, sometimes, well, often we'll find two x values, so two solutions to a quadratic equation. These solutions, these are the roots, right? They're the roots, they're the solutions, they're the zeros, they're the x-intercepts of our quadratic equation. Well, a quadratic equation, a quadratic function, we know the general shape of a quadratic function, right? The quadratic function is a parabola. A parabola can open up like this, or it can open down, and these are just very rough shapes, or it can open down, say like that. Well, both of these examples, they each have two solutions. So the red one has two solutions, two roots, two x-intercepts there and there. My black example, again, two solutions here and here. But could we move around these parabolas so that they might have a different number of solutions? Well, if I take a look here, let's see if it lets me select. It does not. That's okay. If we take a look at this, say, black parabola here, if I wanted to, I could shift this up. And if I shift it up, say, to here, we have just one solution right at the vertex of this parabola, right? So sometimes from our quadratic equation, we'll find that the value beneath this square root sign ends up equaling 0. If it equals 0, then we'll have a plus or minus 0. And if we have a minus 0 or a plus 0, we're going to end up with the same answer. So in that case, if we have only one solution, our quadratic equation itself will come out to just one answer right up here. Alternatively, if we shift this, if say we had a parabola that was in a different spot still, let's say it was even higher, then all of a sudden we don't have any solutions, right? We're sitting here and there are no x-intercepts. If there are no x-intercepts, what we're going to find within our square root sign, right under here, we're going to find something that has no solutions. Something that has no solutions would be something like the square root of negative 9. As much as we know the square root of 9 equals 3, there's nothing that we can square to equal negative 9, right? That would be something like x squared equals negative 9. There's no x here that can satisfy this. So since there's no x, if we have a negative number underneath our square root sign, we'll end up with no solutions. You might see that coming up, and we'll jump into that a little bit more in with our next lesson.